Hello dear students. So today we are going to see now hands-on on classification. But before I actually dive into this topic, I would like you all to revise through the entire topics of classification, because it is a chain of topics that we are doing. To understand this particular topic, you require all the basic information that I have provided you in the previous 3 to 4 classes. Okay, so here I am going to speak today on classification hands-on. Now, we have seen what is classification, and I told you in the classification about a data set that we are going to work on, which was MNIST data set. So, what was MNIST data set? If you recollect, you have got 70,000 images of handwritten digits from 0, 1, 2, 3, so on up till 9. And these 70,000 images have been resized to a pixel value of 28 by 28. Okay, so I told you we are going to use an MNIST data set, and each image is precise to 28 by 28 pixels, and the output is classes from 0, 1, 2, 3, so on up till 9. So whatever handwritten digit image is there, it is going to classify as one of the digits. So you have 10 classes of outputs and image value of 28 by 28 input, 70,000 such images is your MNIST data set. So now we try to build this model. So we went as a strategy. First we understood what was classification based on the MNIST data set that we have picked up, and then we have seen how do we build a particular model, what are all the requirements. Then we had seen why cannot you use a model, simple model, as compared to a linear regression model for this particular data set. You thought you got to know how it doesn't work. Then you know what to incorporate. There were two things. You had to incorporate a nonlinearity. Second thing that you wanted to incorporate was model complexity, and you built a several layer neural network for that. So for classification, you got to know how do you build an artificial neural network with hidden layers, an input layer and an output layer, so that it can give you a more optimized solution. Now I told you, as your model complexity will increase, you cannot rely on manual calculation of gradient descent and gradient descent algorithm. So for that reason, you require deep learning frameworks. So this particular classification is going to use a few aspects of deep learning framework like TensorFlow. Although we have not seen that in detail, in your unit 2 you will be learning about TensorFlow and Keras in detail, but a few hints from TensorFlow we are going to be utilizing in this particular classification problem. I'll make sure it will not be a much problematic thing for you. So so now before I actually move on into the actual code, which you all people are very good at, I am assuming, but we have to understand the basics, whys and hows. You know, simply just going to internet and then copy pasting that code will not work. You have to really understand what functions you are supposed to use, what type of data you are supposed to give, and why you must give. So that is what insight I am going to give you here. Okay, so we are going to see the fundamental concept of coding using TensorFlow for this application of classification here. So as discussed, I am using MNIST dataset, and our first step is to build a network. So now as I begin, we are going to build the network layer by layer. The very first layer that we will come across is the first layer of the network, which is input layer. So when I talk about input layer, I know the input is an image. So I told the image is 28 by 28. So that's why input image is X, which I am keeping, which belongs to a samples 784 samples. Okay, 784 is nothing but 28 by 28 pixel. Now the output of the first layer is going to be served. Now if this is an input layer, then you have the output of the input layer, which is serving as an input to the hidden layer, right? So suppose output of input layer is H1, and then it is going to be, let's say, 256, because the output, you know, try to understand this, you cannot directly decrease the output to the dimension that is required by you. It has to move gradually, then only it can extract the features from the given data, especially when the data is image, you cannot drastically decrease the size of the dimension of your vector, because that is going to eat away the information that is present. And you will study about this more and more in detail when I start CNN for you. So why there is this gradual reduction in dimension, everything we are going to see. So the first thing here that I am going to say, that we are going to gradually decrease the dimension so that you can extract more features and information out of the image. So the first output of first layer serves as an input to the first hidden layer, and let us say it is H1 belongs to R256, so the output vector dimension is 256. So how am I supposed to write this? Earlier you have seen that we would take that particular linear model W1 X is the input, weights associated with it and the first bias, and you would add up a non-linearity which is an activation function. The simplest of them is ReLU, and then I would get an output, right? So we used to manually calculate all these things, but we need not write like this now in our code. We are using here a deep learning framework called TensorFlow, and we will just write a single line code for it. So what I am going to do is, I am going to invoke dense layer from the layers which is already, like, all of these things have been hidden inside this deep learning framework. All the mathematical calculation is encapsulated for you. It's like a black box. You are just invoking it, but things are being done parallelly behind your reachability. Okay, but things will be very easier. Auto differentiations and auto mathematical calculations takes place there. You need not do anything manually that you have been doing so far. So now you have layers dot dense, and then what you are giving there, you know the number of the outputs over there. You have to decide that, and here I have decided that the vector dimension is 256. So I am giving here 256 here, and what is the activation function that I am going to take? It is ReLU. So the moment I give this particular line of code, all that it is doing is calculating this part which we used to do manually till now. So you can understand to what extent is our burden reduced. Now, what is the next step? We require to create a multi-layer network. Definitely we are not working with single layer networks anymore. So for an example, if I want to create a 3-layer network, then what am I supposed to do? I have to take input from one layer, get its output, that output is going as an input to the next layer, the intermediate output is serving as an input to the next layer, and subsequently all these things gets concurrently embedded together. So for that what you require is a sequential function from TensorFlow library. Okay, so if here in this I have taken a sample wherein I am building a 3-layer network, wherein the output of the first layer is serving as an input to the input to the second layer. So what I am going to do here is I am using a Keras API. Now these days TensorFlow and Keras goes hand in hand. Previously they were different, but now Keras API is a part of TensorFlow library itself. So I am declaring a model here. From the Keras library I am invoking sequential function, and from there in that sequential function I am telling that this particular sequential network has got 3 layers. So here you can see I am defining the layers which I just explained to you about. Layers.dense, first I am taking 256, so you can imagine now I have 256 units of neurons. Now gradually 256 output dimension. Now I am gradually decreasing it to 128. So this is my second layer. So what should be my final layer? My final layer is my output. So you all know for the MNIST data set, my output consists of categories. How many categories? 0, 1, 2, 3, so on up till 9. So that means overall 10 categories. So you can see my last layer, which is my output layer, I am going to use with a dimension 10. Mind you, very important thing, for the output layer we are not going to add up any non-linearity. That is the reason when you are ending up with an output layer, you will not choose any activation function. Activation functions are only a part of hidden layers. I am repeating again, please use activation functions with the hidden layers to impart non-linearity to your model. With the output layer we normally, like for a simple neural network, we just stop by giving the number of output dimensions itself. Okay. Now you can see here I just created a 3-layer network, and now what you can do is you can give that input x, which is an image, and we can call the model of x function, and that would give you the output of that particular model, correct? But we also want to optimize this particular model. We want the best best thing out of it. So what do you require? You require optimization. How do you optimize your model? You calculate the loss function, you make subsequent changes, and you make sure that your loss is less. So what I am doing here I am calling now another function. So I am taking from TensorFlow gradient tape, okay, and I am calling it as a name tape. So what it is going to do? It is going to keep a track of my it is going to give a track of my gradient of the loss function with respect to all parameters which is available. So what I am doing now, I had my image, we have P, 28, 28, which I already explained you in my previous classes, which I am flattening now. I cannot use it as a matrix, I can use it as a flattened vector. So 28 by 28 becomes 784, and I first reshape my particular input again, and then what I am going to do is I will get the output from my model by calling model of x, which I just discussed. Once I get my output, I should also have the labels accordingly, right. So I got, what I am going to do here is I am going to use one hot encoding, okay, and I would be calculating the one hot encoded labels of my output, and then I calculate the error function, the same loss function we are going to calculate. So you can see here there is an inbuilt function tf dot square to get me the squared error. So I am going to pass on my one hot labeled output as input to this particular function, and I get a squared error out of it. But mind it, for gradient descent we use mean square error. So I am going to here find out the mean value of this squared error, and thus I get my mean squared error. Now what do we do now? We now calculate the auto differentiation function from TensorFlow, which is tape.gradient function. To that you have to pass parameters of your loss that you have just calculated, and also all the variables that went into this particular model. Using this, it will automatically calculate the gradient partial derivative again, dou L by dou theta. Theta is the n number of variables that a model could have, L is its loss function. You just now calculated loss function, you have to pass on the variables now. Since we have created here 3 layer network, we will have parameters as 3 weights W1, W2, W3, and 3 biases B1, B2, B3. So what we are going to do is, we are going to now use an auto differentiation function from TensorFlow, and we are going to pass on our loss and model trainable variables here. So you can see here, this is what we have done. Once you have done that, what is going to happen inside it? It will apply gradient descent algorithm, and it is going to update the parameters based on the gradient descent values, these values of dou L by dou theta. It is going to apply automatically this particular formula which I have been teaching you for gradient descent, and it is going to update parameters. Nothing manual calculation you are going to do, everything is taken care by TensorFlow here. So now once you are done that, you are going to use an optimizer dot apply gradient, and you are going to apply it to your model over here. So after the multiple iterations, your learned model can be your learned model here, it should be f of theta, okay. Your learned model f of theta can be used to predict the categorical probability of unknown pictures. So once you have calculated your gradient values and you have updated your parameters as per gradient descent algorithm. Why do you want to update? Because you want to have a best fit model. What is best fit model? The model that will give you the minimum loss. So you will keep on iterating it. A gradient descent algorithm internally works unless and until you get suitable values of W1, W2, W3, B1, B2 and B3 that will give you minimum value of your loss. Once you get those suitable values, this is your best model that you can do. Once you have applied those particular weights and biases, you can say that this is the best accurate model that I can find. Now this model is ready to take any input and give you the predicted output as category from 0, 1, 2, 3, so on up till 9. So this was about the hands-on that I could explain you how it goes using TensorFlow. So I would like you to work on this. Okay, take up MNIST dataset and create a 3-layer model and try to get classifications by applying gradient descent using TensorFlow. Now, because what is the conclusion that we have got? Because the 3-layer neural network has relatively strong generalization ability and the task of handwritten digital picture recognition is relatively simple, the training error decreases quickly for this particular dataset I am talking. So, I told this MNIST dataset was not able to solve by a linear model using a single layer. So, we came across by adding nonlinearity, by using deep learning frameworks and by applying more complex model like a 3-layer network. Now, the generalization ability of your model has increased. Generalization ability means you are able to predict correct data for given any training input or test input or any new input. Your output that you are getting is almost accurate. Okay, so generalization is strong with this particular model and you will see that the errors that were present in training were very low, and this is what is the conclusion. And I would like you to note one important definition here. What is this iteration that I am calling? Generally in deep learning we use this term called epoch. So, what is epoch? Iterating all the training samples once is called one epoch. So, you have one epoch means you are serving your model for all the training samples, and then the second epoch and then the third epoch. With all these samples, when you complete calculating gradient descent, it is one epoch, and then you will update. You know, based on that we have seen several types of algorithms also, vanilla, stochastic, mini batch. You know, there are other strategies by which you will implement your gradient descent algorithm. So, iterating all the training samples at once is called as one epoch, and then we can test the model's accuracy and other indicators after several epochs to monitor the model training effect. So, you will see subsequently when we build a model, number of epochs also play a major role in determining accuracy of the model. We will see all these things in future when we try and build more model, but this particular topic was confined to how to build a classification model using TensorFlow for the first time. And in our coming topics, first we will understand what is TensorFlow and Keras, and then as and then we start with our CNN and RNN, you will be having much clear idea on how do we build several models based on the different types of application. So, I would like you all to just pick up an MNIST dataset and create a 3-layer network and try to get whatever accuracy that you could do, and we will see how do we optimize it.